Russ Jackson, thanks for joining us. We're diving into organizing code in Rust. Can you give us a high-level overview of why this is crucial?
Absolutely, Matthew. As programs get bigger, keeping track of everything in your head becomes a nightmare. Organizing by grouping related functions and isolating features makes finding and changing parts much easier. Think of it like a well-organized filing cabinet for your code.
So, you're saying modularity is key?
Exactly. You break down large problems into smaller, manageable modules. This is fundamental in software development.
How does this relate to packages and crates?
Well, a package can contain multiple crates. Crates are like self-contained units of code. A crate can be a library, reusable code, or an executable, a program. As the project grows, you can extract parts of the package into separate crates that can be shared between projects or used as dependencies.
So, you're saying you can reuse code?
Absolutely. Once you've built a module or function, you can reuse it throughout your project or even in other projects.
What about encapsulation? Why is that important?
Encapsulation is super important. It hides implementation details. Imagine a car. You don't need to know how the engine works to drive it. You just use the steering wheel and gas pedal. Similarly, you can call a module's functions without knowing their inner workings.
What about scope? How does that play into this modularity?
Scope controls which names are available within a particular part of your code. Imagine a company with different departments. Each department has its own set of employees and tasks, similar to modules in your project.
So, no accidental name collisions?
Precisely. The module system prevents these collisions.
And the module system is important for?
Scope, privacy of code, and the modular organization of your project, making your code base more maintainable, reusable, and readable.
How does cargo fit into all this?
Cargo, Rust's build system, is instrumental. It helps manage your packages and crates, making it easy to build, test, and share code.
What about paths? What do paths mean in the module system?
Paths are how you name modules, functions, structures, and other things in your code, like a folder path in a file system. They specify the location in your project.
So this whole system of packages, crates, modules, and paths enables a robust approach to building large, complex programs?
Absolutely. It's a way to organize complex software, like a city planning its road system, using clear, interconnected modules.
You mentioned workspaces. What are they?
For really large projects with related packages, workspaces manage them, making it easier to build and maintain your entire project as a coherent whole.
So, everything works in conjunction?
Absolutely. The module system in Rust, encompassing packages, crates, modules, views, paths, and cargo management, is a powerful and well-structured way to design and maintain very large programs.
Great. Russ Jackson, thank you for breaking this down. It's very helpful. Russ Jackson, welcome back to the show. Today we're diving into module paths in Rust. Can you give us a high-level overview?
Sure, Matthew. Imagine a file system. You need a path to find a file, right? Rust paths work similarly to find items in modules.
So, absolute and relative paths? Like in a file system?
Exactly. Absolute paths start from the crate root, the top level. Relative paths start from the current module. Think of it like navigating directories in your computer.
Okay. And these paths use double colons?
Yes, double colons separate the different parts of the path, like directories in a file system. They specify the modules and items within those modules.
Let's break down the example. We have a function add_to_waitlist in a hosting module inside front_of_house. How do we call it?
We use the path to reach it. You can use an absolute path from the crate root or a relative path starting from the current module. In the example, both methods are shown.
Can you elaborate on the absolute path?
It starts with crate, then traverses each module, front__house, hosting, Essentially, a fully specified location.
And the relative path?
Starts from the current module, front__house, hosting, Shorter, but depends on your current context.
Why is one better than the other?
It depends on your project's organization. If you anticipate moving code, Absolute paths might be more robust.
So if you move the front underscore of underscore house module, the relative path breaks, right?
Correct. Absolute paths are more stable. Relative paths are easier to write, but could break more easily if the structure changes.
So we have paths, but something's preventing compilation. What's the issue?
The hosting module is private. Rust modules often encapsulate internal parts of code.
Private? Like hidden parts of a file system?
Yes. Private items aren't accessible from outside the module, like a locked file cabinet.
Why does Rust do this?
To help organize code and avoid accidental changes affecting other parts of your program.
So how do we fix the compilation error?
We need to make the hosting module public. That's done using the pub keyword.
So, basically make it accessible to other modules?
Exactly. Public items are visible outside their module.
And that's how we expose paths in Rust?
Correct. Understanding module paths and privacy is crucial for managing complex projects in Rust. Using the right approach keeps your code modular, manageable, and less susceptible to errors.
Great explanation, Rust Jackson. Thanks for clarifying module paths and privacy in Rust.
My pleasure, Matthew.
Rust Jackson, welcome back to the show. Let's dive into these module paths. This pub keyword seems crucial, but it's a bit tricky.
Yeah, it's about controlling access. Think of modules like containers. The pub keyword essentially says, this container and its contents are open for use from other parts of the program.
So, if I declare a module as pub, does that automatically make everything inside pub?
Nope, you still need to use the pub keyword for specific items within the module. It's like a two-step process. You grant access to the container itself first, and then to the contents.
Okay, so if I just pub a module, I can't directly call functions or use structs inside.
Exactly. The module itself is accessible, but the items within need their own pub. Otherwise, they're private to the module.
So, that's the key to the example's errors, then?
Precisely. The initial errors were because the add__waitlist function wasn't marked pub. The compiler is saying, hey, you're trying to use a function that's not allowed to be called from outside this module.
This feels like financial accounting, in a way. You have different levels of access control for different accounts, right?
Totally. You have an overarching account, pubmod, that's visible. Then, you have specific transactions, pubfn, within that account that might be private.
Interesting. And what about crate? Front underscore of underscore house. Hosting. Add__, waitlist. That's an absolute path, right?
Yeah, it's starting at the very top level, the crates root. It's like you're going from the main office, crate, to a department, front__, house, then to a team, hosting, and finally to a specific person, add__, waitlist.
And a relative path?
Relative paths start from a known location. In the code, front__, house is in the same area as eat_restaurant. So, it uses that as its starting point. That means all the steps after are still within the confines of front__ house, but still with access control via the pub keyword.
So, it's like navigating a company hierarchy.
Exactly. The compiler ensures these access rules are followed. It's a crucial part of preventing accidental access to confidential data or functions.
If I miss something, the code won't compile?
Yes, the compiler is a crucial part of keeping your code structured and protected.
What about situations where you might want to intentionally make something unpublishable?
There are cases where you want to keep something hidden, for example, internal helper functions. You would not want them accessible from the outside.
That sounds like data security in finance. You only expose what you need to for the market.
Exactly. Control over access prevents unintended data breaches.
So, the pub keyword is like a security guard at the door.
Precisely. You grant access only to what you need in a hierarchical structure.
Fantastic. Rust Jackson, thanks for the clarity.
You're welcome.
All right, Rust, we're diving into relative paths in Rust. Specifically, how to use super in module structures. Can you walk us through this?
Sure, Matthew. Imagine a file system. Super is like using, in a path. It says, go up one level in the directory structure.
So, like moving up a folder in Windows Explorer?
Exactly. But instead of files, we're talking about modules within our code. Super tells the compiler to look for a function or item in the parent module.
Okay, I get the analogy. Why use super, though? What's the advantage?
Well, it can make code more maintainable. If we move parts of our code around, we can avoid having to change every single reference.
Let's say we have a back_of_house module. What's the advantage of using super to call functions in the parent module?
In the back_of_house module, if we need to call a function in the top-level module, the crate, super makes that call simpler.
So, if the top-level module contains a function to serve an order and back_of_house has a function to fix an incorrect order, super helps to link them together?
Precisely. Think of it as a cleaner way to refer to parts of a larger program.
So, super is like a shortcut for crossing the hierarchy of modules?
It's like an intermodular highway, getting you from one module to another without detours.
What if the module structure changes?
Using super lessens the need to update code across modules. If later we decide to move serve_order into a different module, we only need to change the references within that one module, not in the many modules that depend on it.
That's a huge advantage for maintainability, right?
Absolutely. It encourages modularity and reduces the risk of breaking things when restructuring code.
Are there any situations where super might not be the best approach?
If you have deep nesting and the relationship between modules is not clear or stable, using super repeatedly can sometimes be less readable and maintainable than an explicit path.
How do we avoid that issue then?
Choosing clear module names and designing a well-structured module hierarchy is crucial.
That makes sense. So, super offers a trade-off between code clarity and maintainability.
Yes. It's a powerful tool for navigating modules, especially when dealing with complex project structures and potentially dynamic code reorganizations.
Thanks for the insights, Rust. That was quite illuminating on how super works in the context of relative paths. We've learned about its impact on code maintainability within modules. Russ Jackson, welcome back to the show. Today we're diving into public structs and enums. Let's start with the basics. Why use public structs in Rust?
Public structs, like public functions, make parts of your code accessible from other parts of your program. Think of it as controlling access to the data within a module or library. It's about creating clear boundaries in your code.
So, if I make a struct public, does that mean everything inside it is also public?
Not necessarily. Crucially, if you make a struct public, only the fields explicitly marked as public are accessible. The other fields remain hidden, sort of like a locked cabinet in a restaurant. Only the staff can see and adjust the contents.
That's a great analogy. So, we can control the visibility of individual data members within a struct.
Exactly. You make fields public using the pub keyword. If you want to keep things private, the fields will be private by default.
This privacy aspect is key to code organization?
Absolutely. It's a crucial part of data encapsulation, like keeping sensitive data, seasonal fruit, perhaps, safely hidden from public access in a restaurant. Imagine if the menu publicly displayed ingredient details. It might reveal how the meal is crafted and impact recipes.
So, using pub for a struct only affects what is public. What happens when we use pub on an enum?
With enums, pub makes all variants public. So, if you make an enum public, you don't have to separately mark each variant. It's a streamlined approach to making things visible.
Why is that a better design than marking each variant with pub explicitly?
Enums are inherently about defining different types of data. Having all variants accessible via pub on the enum makes the code easier to read and maintain.
Okay, now let's look at an example. You mentioned a breakfast struct with toast, public, and seasonal_fruit, private.
Right.
So, if I want to create a breakfast instance, I need a public method within the same module?
Correct. The summer function in the example is crucial. It creates the breakfast struct with a private field preset with a default value for the seasonal fruit, like peaches.
Interesting. What happens if we try to access or modify the private field from outside?
You get a compiler error, which is great. It stops you from accidentally meddling with internal state, making your program more robust.
Now, if a public struct or an enum wasn't public, it wouldn't be usable in other modules, right?
That's correct. Public visibility is essential for interacting between different parts of your Rust program.
Great, Russ Jackson, this makes perfect sense. Thanks for clarifying public structs and enums.
My pleasure.
Hey, Russ Jackson, let's talk about this use keyword. It seems pretty crucial for managing paths in Rust.
Absolutely. The use keyword is like a shortcut for navigating through your project's files. Imagine you have a complex directory structure. Instead of typing out the entire path every time, use simplifies things.
So, it's like an alias?
Exactly. It creates a local alias for a longer path, making your code cleaner and easier to read. Think about how you organize a large project.
Okay, so we avoid typing the entire path all the time. Makes sense.
Exactly. But there's a nuance. You have to define the alias with use. This sets up the scope. This is also where the notion of scope plays a crucial role.
Scope? Can you explain that in relation to the keyword?
Yeah. Scope is essentially the area where a particular name is accessible. If you use something, you're extending the scope to include that item.
So, how does this help with functions in different modules?
Let's say you've got a hosting module inside a front_house module. Without use, you'd have to type front_house, hosting, add_waitlist. Use makes it simpler.
Oh, I see. So, we bring in the whole hosting module?
Precisely. The use keyword brings the hosting module into the scope of the current file. Then you can just call hosting, add_waitlist.
So, we're not just simplifying the path, we're widening the accessible code part?
That's a good way to think about it, yes. This is a key improvement for readability and maintainability.
How does it work with relative paths?
It's slightly different. When dealing with relative paths, you use self. It's like saying, use the name from the current location to resolve this path.
That part is quite subtle. So what's the self keyword doing?
Self in this context specifies that the path starts from the current module, unlike the crate keyword, which suggests the entire project as the starting point.
So, if we're inside a module, we use self?
That's right. This makes the code within a particular module easily accessible and readable, while still respecting the structure of your project.
Is there a potential drawback or a scenario where use might not be ideal?
Potentially, if you have very deeply nested modules, use can make your code a little harder to follow if it's not used carefully. You could risk unintentional overexposure to elements.
That's a fair point. So there's a balance to strike?
Absolutely. It's a powerful tool when used judiciously. It can clean up complex code dramatically.
Thanks for breaking down the use keyword, Russ Jackson.
You're welcome, Matthew. Let's talk about more advanced concepts later, if you like.
Hey, Russ Jackson. So we're talking about using the use keyword in Rust, right?
Yeah, Matthew, we're diving deeper into how use works and how to avoid naming conflicts when dealing with types that have the same name in different modules.
Okay, so you mentioned aliases. Can you give me an example of when you'd need to use an alias?
Absolutely. Imagine you're working with std, fmt, result and std, io, result. Both represent a result, but they're different. Using use on both brings them into scope, causing a name collision.
Right, like two people named John in the same room.
Exactly. Aliases solve that by giving each result a different name in your current scope.
So, how do aliases help us avoid conflicts?
You're smart to ask. You use the as keyword. It creates a new name for the imported type, preventing clashes.
So, you're saying as essentially gives a new handle to the imported type?
Precisely. It's like having an alias for your imported type, creating a local nickname that's unique in your code.
This is cool. So, how do we actually use it? Can you show me an example?
Let's say we want to use std, io, result without clashing with another result. We'd use as. It's super clean and avoids confusion.
Okay, that makes sense. So, you're saying using as with use is a best practice?
Definitely.
So, using as is like a handle or a name tag you can use for that particular imported type.
Exactly. Makes it super clear what kind of result you're dealing with in your code.
But what happens if you don't use an alias and there's a conflict?
Well, the compiler will complain with an error. It helps catch potential problems early on.
Great, that makes it safer. Any practical applications of this in finance, maybe, or software engineering in general?
Definitely. In financial applications, using result types to handle potential errors, you'd want to avoid confusion. Imagine dealing with database queries, currency exchanges, any function that returns data. Clear naming with as helps track results efficiently.
So, as makes your code more maintainable too, right?
Absolutely. More maintainable. More readable. No more headaches.
And how do you decide which name to use when creating an alias?
It's up to you. Something descriptive that reflects the source of the type.
Thanks for the insights, Russ Jackson. This has been great.
You're welcome, Matthew. Glad to help.
Hey, Russ Jackson, let's talk about re-exporting names in Rust. It's a cool technique, but what's the core idea behind it?
So, re-exporting lets you make an item in one module available to code in other modules, as if it were defined in that other module. It's like creating a shared resource.
Okay, so it's about visibility. Can you explain the pub use part?
Exactly. The pub keyword makes the item accessible from outside the module, and the use keyword brings the item into the new scope. Think of it as giving external code a friendly shortcut to that item, even though it's internally defined.
How does this relate to code organization?
Say you have a library for restaurant functions. Internal functions might handle things like add to waitlist behind the scenes. But customers, other modules, might not care about those internal details. Using pub use, you can expose a cleaner, more user-friendly interface like hosting, add underscore waitlist, hiding the complex internal workings.
So, pub use is crucial for creating a cleaner API for your library?
Absolutely. You structure your code however you need internally, but expose a simpler, more intuitive interface for others to use.
What's a practical example of when you'd use this?
Imagine a financial app. You might have complex internal calculations for risk assessment, but you want to expose a high-level function to determine risk tolerance, giving your app user an easy-to-understand output instead of a bunch of internal calculations.
Okay, what are the potential pitfalls? Could it lead to naming collisions?
You could potentially get namespace issues if the items you re-export have the same names as items already in the target scope. It's good practice to keep names clear and intentional.
How does pub use differ from simply using pub?
Pub makes an item accessible, but not reusable in another scope. Pub use brings the item into scope and makes it reusable.
How would you handle potential conflicts between the module and external code naming?
Careful consideration of naming conventions in the module. Prefix naming, e.g., hosting, add underscore waitlist, or using descriptive names are excellent strategies to avoid conflicts.
Let's say a user of your library has a variable named add underscore to underscore waitlist. Does this cause a conflict?
Potentially, but you can resolve these by being mindful and strategic with naming, like pub use super, add underscore waitlist to disambiguate the names.
Got it. So, pub use is critical for well-organized, user-friendly libraries. It allows you to tailor the interface to your user's needs while managing complexity internally.
Exactly. It lets you define a library for your internal use case, but maintain a clear and accessible interface for external consumers.
Thanks, Russ Jackson. That clears things up nicely. Russ Jackson, welcome back. So, we've been talking about using external packages in Rust. Can you walk us through how these external packages work? Exactly?
Sure, Matthew. External packages, like the RAND package we mentioned, are essentially pre-built libraries of code. Think of them as modules of pre-written functions and data structures.
So, how do we bring these modules into our projects?
You tell Cargo, the Rust package manager, about the external dependencies your project needs using the cargo.toml file. It's a configuration file for your project.
And how does Cargo fetch these packages?
Cargo knows where to find the packages from a central repository, crates.io. It automatically downloads the package and its dependencies.
So, it's like a giant library?
Exactly. Think of crates.io as a massive online library where you can find all sorts of tools for various tasks.
But how do we use them in our code?
After adding a dependency in cargo.toml, you bring the specific functionality you need from those packages into your project scope using use.
Using use rand, RNG. You're telling the compiler which elements of the RAND package to use, correct?
Correct. You're importing specific components, much like importing a specific class in Python or Java. It's essential to import functions and traits that you want to use.
So, if we need something from the standard library, std,
Right. The standard library is already included in Rust, so you don't list it in cargo.toml. You still use to bring in specific components.
like use std, collections, hashmap.
Yes, that's an absolute path. You can also use relative paths to components when appropriate. This is really important in larger projects.
Why would you ever need to use an external package instead of writing everything from scratch?
Well, writing everything from scratch can be time-consuming, and reinventing the wheel isn't ideal. External packages are often optimized, tested, and maintained by a community of developers, so they are usually more reliable than something you write yourself.
Does this efficiency and quality matter in financial applications?
Absolutely. In finance, speed and accuracy are crucial. Using pre-vetted packages reduces the risk of bugs and errors, which is critical for financial modeling.
So, what's a common mistake people make when using external packages?
Forgetting to use to bring things into scope. They might have the dependency in cargo.toml but not the import in their code, resulting in compilation errors.
That's a common gotcha. So, what about cases where external packages aren't well maintained or have potential security vulnerabilities?
That's a valid concern. You need to be mindful of the package's reputation. Good practice is to check its popularity, history of updates, and community ratings on crates.io.
That makes sense. Great explanation, Russ Jackson.
Thanks, Matthew. Using external packages is a vital part of leveraging the Rust community's expertise and making your projects more efficient and reliable.
Welcome back, Russ Jackson. Today we're diving deeper into organizing Rust code. You mentioned separating modules into different files, right?
Yeah, managing larger projects becomes a lot easier with this technique.
So, tell us about this. Why would you want to split up modules?
Think of a huge spreadsheet. Trying to find something specific becomes a nightmare, right? Similar with code. Large files get unwieldy. Separating them makes the code base more readable and maintainable, like having separate worksheets in a spreadsheet for different data. You can quickly locate the relevant information without digging through everything.
Okay, that makes sense. Walk us through the practical steps.
We start by moving a module to a new file. Let's say we have a front_of_house module in one file. We move it to front_house.rs. The important part is adjusting the main file to correctly reference the new file location for the module.
What about the code that uses the module?
The code that uses the front_house module will use a pub_use statement to import the necessary parts from the module. It essentially creates a pathway for the code to access those functions and data. The crucial point is that the module name and its specific parts are referenced correctly in the new files. If this isn't done right, we have to fix all those references in the original code.
So, like creating an index to quickly get to different sections?
Precisely. By moving modules, we create a more organized structure, making it easier to update and debug, like having specific tabs in a big document.
You mentioned mod statements?
Yes, the mod keyword in Rust declares a module. Essentially, it tells the compiler how to find the code related to that specific module in its separate file. A bit like a table of contents.
What happens if we don't use pub_use?
You wouldn't be able to use the functions or data from that module in other parts of your code. You'd need to explicitly import each item. It's like having to find each page manually.
What are some real-world applications?
Imagine a finance app. You could have separate modules for managing accounts, trading, and reporting. Each module can be a separate file, making updates simpler.
What are some potential pitfalls?
Forgetting to update the imports correctly. That would cause errors. Or having cyclical dependencies between modules.
So, organizing code with separate files makes things cleaner, but it comes with its own challenges.
Absolutely. It's a trade-off between clarity and potential complexity. But if done correctly, modularity significantly improves maintainability, like having multiple, well-organized spreadsheets for a financial analysis.
Excellent insights. Thanks for sharing.
You're welcome.
Rust module system, huh? So, how do these modules actually help us organize code? Like, what's the practical benefit?
Well, imagine building a huge financial application. Without modules, your code base would be a tangled mess. Modules let you divide and conquer. You create smaller, manageable pieces of code for different features, like a trading algorithm module or a risk assessment module.
So, it's like building Lego sets?
Exactly. You can assemble these smaller modules into larger systems. And this modularity makes your code much easier to understand, maintain, and even debug, especially as your project grows. Imagine having 100 developers working on a large financial system. It's crucial to keep it organized.
Okay. And how do you reference code across different modules?
You use paths, sort of like file system paths, but within your code. You can use absolute paths, going all the way from the root, or relative paths, starting from your current module.
So if I have a function in one module, I can call it in another module?
Absolutely. And you can import a whole module or just specific items within it, using the use keyword. That saves you typing and makes the code readable. Like a shortcut.
Wait, so there's a way to share code easily?
Yep. You can also make modules private, meaning they are visible only within their own scope. If an item is public, you can call it. And that's important for controlling access.
Why is this important in financial contexts?
Privacy and security are crucial in finance. A company might want sensitive components accessible only to authorized modules, not every part of the system.
But if I need to use something from another module, does that mean I have to rewrite the entire module?
No. That's the beauty of using use. If you frequently need to access something from a module, it's a great idea to use it.
So, what about if a module has multiple items with the same name in other modules? How does that work?
You specify the module name to avoid conflicts. It's like having different streets with the same name in different cities. You'd need to specify the city name to disambiguate.
Cool. That's clearer now. So, are there any potential pitfalls or common misconceptions about modules?
Well, one pitfall is relying too much on relative paths. If the project structure changes, you can end up with broken code.
Sounds like it's a good idea to use absolute paths then?
Using absolute paths is a good idea to avoid that. They don't change when the project structure alters.
Thanks for clarifying that. This module system sounds pretty powerful.
Yeah, the module system is super powerful in Rust. It's crucial for creating maintainable and scalable applications, especially in the finance sector.